Welcome back, geometry students. This is Mr. Martin. These are video notes for section 7.1, transformations and symmetry. So as always, if you have questions, pause the video, write the questions down, make sure you ask those the next time you see me or your teacher. If you missed something, pause the video, rewind it if necessary. Make sure you get the help that you need. All right, so a transformation, this is a general term to describe four specific ways to manipulate an object. So we've got these four ways that we're going to talk about. What does that really mean? If you notice here in these pictures, I have on the left, the original picture here is outlined in black, and it has vertices A and B and C. And then my new picture, we call that the image. So we've got the original, and it turns into an image. And if you notice, all of the points that match with each other, this one said A, this one says A with a little apostrophe up there. We say A prime. So here's B, and here's B prime. And then here's C, and here's C prime. So we know which is the image because we put that little apostrophe, and again we say prime. So we can see that this original triangle has basically been moved over to here. And we'll discuss what that means in just a moment. All right, same thing over here. Here's my original image, and it's been moved over to here. And again, you can see the original image was D, E, F, G, and the image is called D prime, E prime, F prime, G prime. So that's standard notation. It is required, so you want to make sure you do that. And that avoids any confusion of knowing which is the original picture and then which is the new picture or the image. Okay? So let's talk about rigid transformations, and these are also called isometry. So that's a fancy vocabulary word. If you're keeping track of the vocabulary somewhere, you're going to want to add isometry to that. So a rigid transformation, this is a transformation where the image is congruent. Okay, here's another vocabulary word. To the original. Okay, this word congruent, this is equal in geometry. So instead of saying things are equal in geometry, we say that they are congruent. And we'll talk about this more also, but another vocabulary word that you want to commit to memory. If things are congruent, then they have exactly the same size and shape. Again, it's the equal sign of geometry. All right, so here are three types of transformations. We have number one, a translation. We have number two, a rotation. And number three, a reflection. Okay, and this can get a little bit confusing if you think about what we have previously done in Chapter 0. In Chapter 0, we were looking at a single figure and deciding what type of symmetry it had. Okay, for these, we use some of the same words like rotation, but now we're taking a whole object and rotating it to a new spot, instead of rotating a single figure to see if it will match up with itself again. So a translation is basically sliding to a new position. Okay, so we just slide it over. Okay, a rotation is turning about a point to a new position. And then a reflection, this is flipping over a line to a new position. So the key words in these basic definitions here, it should be sliding. Let's make sure we fix that. Sliding. Okay, so basically this one is a slide. This one is a turn. And this one is a flip. Okay, so these are two types of transformations. And again, if we come back up here, these are called rigid transformations or isometries. Okay, notice that the shape does not change, just the position where it is on this grid does. All right, so now let's take a look at these eyes here. If you notice, when we go from here to here, it got smaller, and when we went from here to here, it got bigger. So the size of it did change. So where before we had a rigid transformation, now we have a non-rigid transformation, otherwise known as a dilation. So if you think about your eye dilating, the size of your eye is changing shape. So a non-rigid transformation or a dilation is a transformation that does not preserve size or shape of the original object. Okay, so again, this eye is getting smaller, and then the small eye is getting bigger. Those are dilations. All right, so what I want you to do is go ahead and pause the video and see what you can do for this example 1, and then when you come back, we'll go over the solutions to these. So it says, are the following rigid or non-rigid transformations? So go ahead and pause the video, and then when you restart it, we'll discuss those. Okay, so this first one, if you notice, we've got this point F over here, and it appears that we've just rotated the figure to get to the new spot. So this would be a rigid transformation or an isometry. So it is rigid. The shape of the new figure does not change. Now this other one, we see here's the original triangle, and then the new triangle is taller. Okay, so if we went from a short triangle to a tall triangle, that means that this is a dilation, and it is non-rigid. Okay, so that brings us to the end of this video. Go ahead and do the think about it, and recap it. And if you have any questions, make sure you, again, ask me or the other teacher when you see us in class. And we will see you in the next video.